Okay, we'll kick off. So again, thank you so much to everyone that's jumped on. We had a heap of registrations for this webinar as people's first webinar. Though also a whole suite of people that registered for the series, which we really appreciate as well. I was just thinking, if there's anything, you're on here today. If there's, you'll see what we covered today. If there's anything you feel we haven't covered through this, any questions you've got, anything more you'd want to explore, more than happy to pass out some advice. So, please don't hesitate to get in touch. You'll have our email addresses and contact details and things like that. Happy to answer any questions. So today we have Adam Ward again. Adam's the Chief Technology Officer for BIM Store, TwinView, and BIM Technologies. They're three of the Space Architects Space Group companies. And he's going to talk about some of his experiences as to where BIM is functioning, really at the cutting edge at the moment. RIA webinar, episode 6, Future Trends, how BIM will evolve. And I think as part of that, I know we've got a lot of product manufacturers registered and signed up. He'll talk to how manufacturer data and intelligent aids, in the digital built world, on that forefront in digital twins and decisions and things like that. And I was thinking, it's worth mentioning Adam is based out of our UK office, and it's worth mentioning that, the forefront of BIM for the UK, the most developed BIM market in the world is probably a bit different to Australia. And but I would still say, there are a lot of agencies in Australia drawing on what they're doing in the UK to make good decisions about buildings, make good design decisions, good life cycle decisions and whatnot. But I think it'll just be a really, what Adam will have for us will be a really exciting look into the future about where this data and design can take us. So yeah, same format as previous webinars. Ask any questions in the chat. We've got Paul moderating. He'll send those through to me. We'll try to get through them. Adam has about 35 minutes of information, and we'll try and get to 5 or 6 questions, and then we'll let you go. So we've got Adam, and a quick plug as well to, we're obviously at episode 6. After today's episode, most of them are already up there, but we'll have the full suite of webinars online, and we'll communicate that to anyone over email. And if you want to send them on to anybody, that could work as well. Okay, so I will hand over to Adam.
Thanks, Tyrone. So I think Tyrone's did a good introduction there. So I'm Adam Ward. I'm CTO of Space Group, and in Space Group there's various companies. I'll give you an overview of those companies as part of this presentation. But essentially what we're going to cover today is who's BIM Store, what do we do? We're going to have a look sideways into other sectors, because a lot of people think BIM is new, and in reality BIM's not really new. It's new to the construction industry, to the EC industry, but it's not actually a new concept. It's been around for 20, 30 years in other industries, just under a different name. So we're going to have a look at that before we actually look at BIM today, and then we're going to have a look at BIM tomorrow. So we're going to show you some real world examples of what's possible once, as a manufacturer, you have data rich, good quality parametric content. We're then going to move into some examples of manufacturers who we think's done it well, so Sunbelt Rentals and Travis Perkins. Then we'll leave some questions at the end for anyone. So yeah, Space Group. Space Group is a number of companies. There's 4 companies in the group, 60-year-old business. At the forefront of digital construction back in the day. One of the first architectural practices in the UK to adopt Autodesk Revit back in 2007, I think it was, before Autodesk bought it. And since then, developed a company called BIM Technologies, which I was involved with, which is a BIM consultancy. And I believe Anthony from BIM Technologies spoke last week on ISO 19650, etc. Then BIM Store came around in 2011 because we realized manufacturers needed a place to distribute their content, but also there was a lack for good quality content in the industry. So we developed BIM Store. Essentially, I described it as Amazon for BIM objects. You want a BIM object, you can go and look at the manufacturer's website and you're taking a risk about quality, who's made it, what you download, and go to BIM Store, guaranteed quality. Then the latest company is TwinView, which is a digital twin. So it's what building owners and operators use to manage their building during operation. So that's where all this BIM data goes at the end of the day, kind of goes into the client's operational phase. 4 businesses in the group. Everything's about trying to improve the construction industry and trying to kind of complete that circle from design all the way through to operation. So we have companies in each sector. BIM Store, I describe it as Amazon for BIM. Yes, there's BIM objects all over the shop, different quality, taking a gamble with what you're downloading. So we created BIM Store that everything on BIM Store meets a standard. It's all built to the same standards. So if you download from one manufacturer, it all meets our requirements. And really easy to find content, completely free for architects, designers, engineers to go and download BIM content. Hundreds of manufacturers, tens of thousands of objects, products on there, actually hundreds of thousands now. So it's got a community of millions signed up to it. So it's a hub for BIM. If you're an architect or engineer and you need BIM objects to actually design with, TwinView's kind of in Europe one of the biggest portals for that. What not a lot of people know about BIM Store is actually more than just a front-facing website for designers. We also power an ecosystem of internal private libraries for manufacturers and third parties as well, such as Travis Perkins, Barrett Homes, Little supermarkets. We power their infrastructure. So if an architect's building a new supermarket, Lidl will give them access to their library of information. And obviously, we also distribute your content, not just on our platform, but we push it into other places such as Bentley, Unified, TwinView, ActivePlan, etc. So it's we're a distribution platform for manufacturers' content. Updated on BIM Store, updates in all these places with one go. And of course, analytics. So as a manufacturer, if you want BIM Store, you get access to all sorts of analytics about who's downloading your objects, search terms, and data about how your products are getting specified. So that's enough about BIM Store. I'm now going to kind of focus on, I'm going to move sideways and look at other industries. So I'm going to use a couple of cliches here, and I apologize for that in advance. But it's a really good analogy. And I think what I'm going to show you at the end of this presentation will circle full back to what I'm about to show you now. So this is the Ford production line, one of the first cars coming off the production line. And you can see quite automated, well, not automated, but it's the first production line facility, for cars. People building the cars on a production line. This is the Mini coming off the production line back in 1960-ish, I believe. But again, that was high tech at the time, quite advanced. And if we look at how the Mini's produced today, there's no humans on the line. It's completely computer controlled robotics. And of course, you couldn't do that 20, 30, 40 years ago because you need 3D data. These robots feed off 3D data and you don't work off 2D drawings. You need 3D information to allow them to do this. So we call it BIM in other industries and you call it digital prototyping. But essentially, somebody like BMW would design a car inside a computer in a bit of software, probably CATIA, and he would design every nut, bolt, screw, wire and harness, every spark plug. And what he would do is those parts he would get from their suppliers. So again, if you've got a Bosch fuel pump in there, it'll actually be that fuel pump that's actually put into that car to check it fits in the engine bay, and then also do other things like analysis, simulation, crash. You can crash cars virtually now instead of doing it in the real world, but also for marketing and images. So the images you're seeing on the screen now from Honda is actually the digital prototype, which is used for fabrication, but they use those models also for advertisements and things like that. So you can actually do an advert for a car before the car's you've even built one, because of these digital prototypes. And this is an example of that. So this is what's called the Blackbird. And essentially you overlay the 3D model of the car on top of that. And then, yeah, so you can have the adverts ready before they've even produced the car, technically. And if you look at how cars are operated, like Teslas or any modern vehicle, those cars are sending telemetry data back to the headquarters all the time. What speed you doing? Have you went over speed bump? Is there any error codes? That data is getting fed back to the mothership. For example, when I went to get my car serviced, he recommended what tyres to put on it because he analysed my driving style over the last 10,000 miles. So that's the type of stuff you can do when you have this kind of connected ecosystem of data. Oh, I'm going the wrong way. And also standardization. So looking at BMW Mini, same company, it's the same wheel hub on a BMW Mini as it is on a 1 Series BMW. So by breaking it down into a kit of parts, it's helping manufacturing processes, it's making it easier. And you can start to see how kind of the relationship with BIM and BIM objects come into here. Essentially building a car as a set of parts from different manufacturers, come together to build a vehicle. That vehicle can be simulated, tested, rendered, etc. Another interesting fact, if we look at IKEA, you may not realize, but 75% of all renderings in an IKEA brochure are computer generated. You're not actually real images. So yeah, 75% of them are computer generated because you can tweak them, you can adjust them. And obviously IKEA, it's all standardized parts. You can build them, you can prototype them and basically set scenes quickly, change them quickly without needing to physically go to the hassle of building sets and taking photographs. So this is a computer generated image from the IKEA catalogue. It's as good as a photograph, right down to food in the bin, to plates in the dishwasher. So 100% computer generated from 3D digital objects. So now look at aerospace, exactly the same. This is the Wright Brothers factory back in the day, hand-built aeroplanes, prototyped. Now aeroplanes are designed in a computer, right down to the nut bolt screw level. Again, in a software called CATIA normally, but that allows them to be optimized and tested. So this is a Bourne production line in the factory today. And I realise probably Bourne's not the best example at the moment with all the problems they've got. But essentially, you can now, this is how they used to test aeroplanes. They used to bend the wings till they snap. And now we've got the computational power and the data from all those tests to be able to do this inside the computer. So CFD simulation and fine element analysis, FED analysis, to understand, hey, let's not go and destroy a 300 million pound aeroplane for a test. Let's test it in a computer and maybe destroy one at the end to validate those results. And again, because we're building these planes virtually inside a computer, we can build the different parts in different parts of the world by different companies and ship them together, and they all fit together perfectly. Even though in different countries you've got different standards for things like wiring, because it's digitally prototyped in a computer, when it comes together, it all fits together perfectly. And if we look at how aeroplanes are operated, aeroplanes have a highly sophisticated maintenance scheme, and it runs off a bit of software called Maximo. And essentially, every aeroplane in the sky sends telemetry data back to a data center in Birmingham, owned by Bourne. And what that's doing is it's monitoring thousands of sensors on that aeroplane. And if it finds any problems, it checks the nearest airport, it checks the inventory in that airport to make sure you've got spare parts to service that plane. And it'll even redirect that plane to a different airport based off who's on shift, what tools are available, and then you have spare parts in that airport. And all this happens autonomously on the cloud without any human input. So again, really sophisticated from like a PLM facilities management perspective. Now, if we look at our industry, the construction, architecture, design, EC industry, this is how we used to design buildings on a drawing board. Some people still do. We moved to CAD, essentially doing what we did on the drawing board, but doing it in 2D, so drawing lines, arcs, and circles, doing it on a computer screen rather than on a bit of paper. A lot better because you can copy and paste, you can duplicate things, etc. You don't need to scratch stuff out, but essentially still a manual process. It's not intelligent. It's still 2D information on a screen. Then more recently, the latest generation, we're talking about BIM. So now more architects, more engineers are now designing in 3D, especially bigger, more complex buildings. We're now starting to design buildings like we would design a car or an aeroplane. We design them in a computer, test them in a computer, etc. So again, if you look at the aerospace industry or the automotive industry, they've been doing that for 20 years, longer than 20 years, 30 years. And like I said, everyone thinks BIM's new, but really we're just following the trend of 3D digital prototyping. And the reason is buildings are getting more complex, regulations are getting more stringent. So this is Victoria Gate in Leeds. You can see how complex this is. Can you imagine trying to design this in 2D? I'm sure someone could, but I couldn't. Trying to make sure all those bits fit perfectly and everything lines up, and hope when it gets shipped to site, everything fits. So this is why digital prototyping is becoming more and more, or BIM's becoming more common, because buildings are getting more complex. This is the inside of that building. So again, the architect just went mad. Let's not have any straight lines, everything curved and funky. Even curved glass. Yeah, so this is would be really difficult to design in 2D or traditionally. And you can see the complex. So this is the same project, Victoria Gate in Leeds, and you can see this lattice here. Again, it's not just helping the design process, but also when it comes to construction. So when it comes to site, the contractors need to make sure these things are going to fit together like Lego. So for example, these are manufactured in Amsterdam, these concrete panels. Yeah, the steel works manufactured in the UK in Sheffield. And when you both come to site, you've got to fit together with millimeter accuracy, because you can see the dowels and the holes on here where the pegs have got to go into. Luckily, because of BIM, we can test that virtually in a computer. So we can bring those parts together. It fits, and obviously the drawings are produced from the BIM, so when it goes to site, it should come together perfectly. So none of this is really cutting edge. This is kind of how BIM's used today, to kind of coordination, clash detection, etc., etc. 4D sequencing, timelining. This is a project in Brent Cross, London, shopping centre. So this is the 3D rendering, but behind the scenes, there's a BIM model. So this is the BIM model of Brent Cross. And it goes right down to names on the signage. So again, can we check that signage is clear? Can you see it from that angle? Modeling every single part of that building to make sure that, yeah, it works. This is Google's King's Cross building. So again, this is the building. It's as tall as the Shard, but it's like laid on its edge in King's Cross, London. This is the BIM model inside of Autodesk Revit. And you can see the structural model there, built by the structural engineer. You can see the mechanical model built by the MEP engineer with all the mechanical elements in it. And they all come together. This is the cold drop yards. Again, you can see the BIM model on here. So BIM is used throughout the industry. It's kind of commonplace now, I would say, especially in the UK. It's can't comment for Australia, but in the UK, it's kind of everyday stuff, even for small buildings. So the question is now, how as a manufacturer does this affect you? So this is in the old days when we used to do designs in 2D, we used to use stencils. Manufacturers used to issue these stencils to people. Just Shanks used to send me a toilet stencil with a little to trace around. Then we moved to CAD, and essentially manufacturers start giving us 2D CAD blocks. So instead of having to paste that furniture, paste that boiler into draw that into a CAD, we could just copy a block from the manufacturer, put that directly into the software. With BIM, we've moved to the world of 3D, so we now have 3D BIM objects. But it's more than just a 3D BIM object. Obviously, this object has data, it's got parametrics in it, so it's configurable. You can have 1 boiler, 2 boilers, different heating outputs. When you change that, the data updates automatically, etc. But then also, it can also have nice to haves. So, for example, let's say the architect wants to see, will the clearance zone be achieved? You can have a little tick box to show the clearance zone, for example. So, as a manufacturer, architects are now expecting manufacturers to provide this content. But what I would say is it's got to be good quality content, and it's got to be useful content. So a CAD block, 3D CAD block just loaded into a Revit file isn't good. It's got to be good quality, efficient, data-rich content. Now, this content's also got not just the manufacturer's data, it's got heating information, energy rating, how heavy that is. And you can see on here information which is used to do analysis and calculations. And you can see manufacturers are now starting to also provide libraries of content. So this is a stair manufacturer, Staircraft. Yesney built-in clearance zones to make sure you get in the headroom. Again, little features which is giving the architect incentive to use this content. So your nice features which make the architect's life easier, and providing that as a library of content. Pardon me. So this is a roof truss manufacturer providing Barratt Homes standard roof truss designs for all roof trusses. So some manufacturers are now starting to offer a design service in BIM. So the manufacturers are now designing using the BIM software themselves and providing whole packages to contractors and architects. So for example, I've designed a house, I want a roof truss package. I wouldn't have to sit there placing each truss. Manufacturers are now designing those systems. And you'll see on here another one, a library of parts. A lot of clients, such as Bovis Homes here, who aren't architects, aren't engineers, are now starting to provide library of content to their designers. So if I'm designing a new house type range for Bovis, they're giving me the bits to build their houses with, to make sure I don't go mad and specify a gold-plated light switch when they've got a supply agreement with Dieter Electrics, for example. So giving architects and engineers the component parts to help build those buildings. Barratt are doing the same. And I think what's super important here is to make sure that the content that is built is suitable for everybody across the whole life cycle of the project, all the way through from design, all the way through to operation. If you ask an architect what data should be in a BIM object, most of them won't care about the energy, the heating capacity, the BTU rating of the boiler. They won't care. But if you ask an MEP engineer who has to do the heating calculations, he'll want that data. If you ask somebody who's operating the building, they'll want the warranty information. So what I would say is that the myth of too much data in a BIM object is a myth. You can't have too much. It's got to be good quality to standards, but really these days with the computers we have and the power we have, yeah, more data the better, as long as if it meets standards and is to industry standards. Make sure you build content which is used for the whole life cycle, not just design. And again, most architects will be using these objects to build a model which produces all the drawings for them, essentially. Again, the days of producing separate drawings are gone. But a lot of BIM software, like Revit, for example, can also do analysis. And you need to make sure when you're providing your BIM content, it contains the data to allow this to happen. So if you're building a structural beam or column in Revit, make sure it has the right material properties to allow the calculations, etc. Because it can do mechanical flow rates, it can do structural analysis, lighting analysis directly in the design software as the designers are designing. But that's powered by data which is in your objects. And you'll see an example of that later. The other good example is make sure the materials are on your objects, because these are some renderings direct from BIM. So these renderings are have come from the BIM software itself. And again, making sure your objects have the material on and the correct information on is super important. And this just shows it's not just a pretty box with textures on. If you actually cut a section, you're still getting all that detail, because this model's the same model which produces your 3D visualizations. So you can see the METSEC in there, you can see all the valves and bits in here. And again, if I clicked on one of those valves, it will have the manufacturer's name, etc. So this is a BIM object. So obviously this is in low detail, you have medium detail, then you have fine detail, or LOD, level of detail. There's different levels, depending what country you're in, different standards. But make sure your content's usable for everyone. Whether it's for schematic design, you just need a box, or whether it's for detailed design, or whether it's for 3D visualization, make sure your content has all the data to allow that to happen and is built to standards. You don't need to go too far. So a lot of people say, well, do I need to model the screws and little bits and pieces on there? So I would say these days you don't. So this is a 3D visualization done by one of our internal visualization artists in Space Group. And this is a quick 20-minute rendering directly from Revit. And what you'll see in here, there's not much detail. It's quite a basic one. But what we can now do is chuck that through stuff like Da Vinci and different AI algorithms and tell it to make it look better. And you can see it adds the detail. So you can see if you look at the roof trusses up at the top, it's adding lights, it's adding pipes, it's adding wires. If you look at the detail on the train, it's adding a lot more detail. So that's just using machine learning, chucking in images and, hey, make this image better. Here's another example. So a really basic rendering from Revit. Again, quite bulky, quite washed out. Chucked out an machine learning algorithm, especially if you watch this guy's face here and this guy's face here and this detail up here, you'll see it kind of just adds that next level of realism. So these days you don't really need to model every nut, bolt and screw, because that's going to kill someone's machine, but build what's appropriate to get the dimensional context across and get the information across. Obviously, these BIM objects are then also being used in AR. So this is a project which Barrett Homes did. They built the whole house using manufacturer's BIM content, and then a competitor's house. And then at their yearly management conference, they stuck headsets on everyone and said, hey, go and walk around one of our products, one of our houses, go and walk around one of our competitors and do a checklist about kind of why we better than our competition. So we developed this app for them as BIM Store, which allowed them to do that. And essentially, you could go through using AR or virtual reality with a VR headset and basically spot where the difference is. You can fit a car in the garage, you can't fit it in the other one. Stuff like thinking about furniture locations, etc., etc. So again, VR, once you've got the data with the materials, with the models, this stuff kind of is like a freebie, for want of a better word. A lot of clients are asking for BIM. So a lot of reason people are doing BIM is because the client's saying, I mandate BIM, I want BIM on this project. And the reason for that is at the end of construction, that BIM model and its data gets handed over to the client or extracted out in a format like Kobe or similar and handed to the client. But a lot of clients are now starting to use these BIM models themselves for operational. So for example, in the past, we have to have a copy of Revit, which is £8,000. You need to know how to use that. Now we can shut down something like TwinView and allow them to go and actually see that, click on it, get the information. So clicking on a boiler, for example, here, go and click Manage, seeing all the manufacturer's data, the manufacturer, the data, getting access to all the user guides and manuals which are built into the content. So again, this is just like a byproduct at the end, kind of. It's a visual way to see all that data you've put in going back into a digital twin or a CAFM system. So yeah, there's many reasons for BIM, all these reasons here. But really, you've got to think about BIM from the life cycle, from design all the way through to operation. What do people need, and what use cases are these objects going to end up in? So I'm now going to show you some good examples. I've already did this. I don't know why that's in twice. So let me talk about Sunbelt. So this is a manufacturer we built BIM content for, Sunbelt Rentals, I think around the world. Yeah, we built all their content in BIM. We host it for them on BIM Store. So you can see, you can go to BIM Store, you can download this content. This content's really cool. You can adjust the angles, you can adjust the lights, you can extend the booms. It'll have maximum reach built in, turning circles built in, etc., etc. Yeah, so I'm going to give you a quick little look at this content. I'm going to show you how they've taken it to the next level. So yeah, so essentially architects can get this content. It's got stuff like, if it's a lighting tower, you can see the extent of the light. You can stretch the content and automatically adds extra stuff in here. So you can see I can turn on the lighting patterns to see where the light's going to project. We've modeled the lifting hooks with little markers on, safety zones. So rather than just provide the object in 3D with a bit of data, we've added all these little useful things which make the end use of this product better, including all the accurate lighting definition. So the IES files loaded in. So you can angle, you can tilt the lights, and it will actually calculate your lux levels based off that. And of course, if you render that in Revit, as you'll see in a second, that will render accurately because it's got that data built in. So really good content that is more than just a 3D object with data. It's got useful things built in to allow you to actually understand, hey, where's my light going to go, etc., etc. And it can be rendered, obviously. Now, Sunbelt also use these objects internally because they've got a design business. Let's say you're doing Glastonbury or you're doing a festival or concert. They will design your site, put your barriers around, where your toilets are going to go, where your lighting's are going to go, and they'll design that. And they've got an internal design team which use Revit, using their own content to actually provide this service. So you're not just providing this content to third-party specifiers, you're also using them themselves to form part of a design service. And you're doing because they had all this content built, you thought, hey, let's stick it in a VR app. So we built them with BIM Store. We've built them augmented reality app, which you can go and download from the App Store now if you're in the UK, and it'll allow you to place the object on site, see all the data, see the documentation, but actually put that on your site and see will it fit. So if you want to clean your gutters, for example, you can go and place that object in and see if that device will actually reach. So again, another use case where before you could have built that up separately. That was a lot cheaper, a lot more efficient because we already had BIM with the data in to do that. So we already modeled the clearance zones, the lifting capacities, the 3D objects. So really easy to do that based off that data. So another advantage of where it's not just about BIM for construction, design and construction, that BIM data is also being used for other purposes to help them market and sell their products. So if we go all the way back now to that car coming off the production line, what I want to show now is kind of the whole circle. So how you can design a house on a computer in a couple of minutes, press a button, and then robots build your house for you. So this is Travis Perkins, one of the biggest builders merchants in the UK. He's been a customer of ours for years. And they came to us and said, hey, we've modeled everything you can buy from Travis Perkins, we've modeled in BIM. We want to start selling houses with that content. And we want to sell houses like people would buy a car. Configure a house on a website, press a button, you get all your construction drawings and a bill of materials, and you can go into any of our branches and order those parts. So this is called Whole House. Again, you can go and look it up and have a go on it if you get a code. But essentially, your website, you go on, you design your house. So you pick a standard 3-bedroom, 2-bedroom. You go on, you can change obviously your bricks, your colours. You want render, you change your front door. You want solar panels, you want chimneys. You can go right into the detail of kind of which type of heating system you want. And again, this is all built using real manufacturer's content, which I'll show you in a second. Like staircases, door handles. Yeah, and you can kind of go and design your house. It'll give you a real-time price based off their back-of-house pricing system. And then you can put that on a site, pick a site location, click order construction pack here, press buy, and about £1,000 later, 20 minutes later, you have a full set of construction drawings exactly as per you configured. So these are true construction drawings with sections, plumbing diagrams, and everything is exactly as per you configured. And this is all without a human touching it. Not only does it do all your construction drawings for you in details, it also gives you a full bill of materials with what products, what parts, how many you need, etc., etc. And then you can walk into any Travis Perkins and call off those items and basically guaranteed price for a house after 20 minutes. The really clever bit about this is, though, is as you're configuring that house behind the scenes is a really detailed BIM model. You can see even when you move a radiator, add a radiator, it's putting the timber in behind the scenes to allow for that. So right down to Patterson and that level of information. And you can see some of the detail on here. So it's not just a 3D image, it is a full-on BIM model being configured. Yeah, right down to the detail. And obviously that's used for renderings and stuff like that as well from that. But the really cool thing is we thought, well, wouldn't it be cool if we could work with a company like Top Hat where we could drive robots in the factory? So this is how Top Hat used to build buildings, essentially humans building buildings inside a shed and then shipping them to site on the back of a truck. This is called Factory One. The problem was to design a house took longer than it did to build the house. You could build a house in a day, but it took 2 weeks to design the house. So we used our Da Vinci platform to actually allow someone to configure a house exactly like you've just seen on Whole House, press a button, but then that data gets converted to G-code and a lot of other clever things, and basically that then goes and drives robotics in Top Hat's factory. So the idea is you can go from computer screen order all the way through to a house coming out of your factory in less than a day, all without any human input. So this is only possible when you've got that 3D data. So if you look at the car example, how cars are now being made by robots, you can see how we've come full circle. We're getting to the point now where if you've got really data-rich, controlled BIM data, what you can do is you can use that to drive fabrication a lot easier. So again, optimizing that construction process. So I think I'm going to leave it there. I think that's give you, I think, an overview of kind of where BIM is today, where it's kind of cutting edge, where it's being used, more than just, hey, here's some objects for an architect to stick in the model, and show you how that's being used by a couple of different manufacturers and a couple of different customers there. So yeah, I don't know if there's any questions. I'll hand back over to to Tyrone. You're muted, Tyrone.
Gotcha. Thanks for that. Amazing. Thanks, Adam. I hadn't seen too much about Whole House. That's pretty amazing. A question came in right as you're talking about it. I'll start with that one. How customizable are the Whole House designs? I think that probably means like can you move rooms around and things like that.
So yeah, so customizable within reason. So you can't move rooms. That's why you've got to pick 2-bedroom, 3-bedroom, 4-bedroom. Doesn't go to that level, but you can change your door, move your door. You can move a wall. What you can't do is you can't change the fundamental massing of the house, if that makes sense. You can change cladding. You can change kind of the fabric. You can make your windows bigger, etc. But you can't fundamentally change the footprint. And the reason being is obviously the system doesn't let you get into trouble. It won't let you design something which doesn't meet standards, like Part L or otherwise. So there's certain constraints, but generally, yeah, I think there's 2.6 billion possible combinations you can have on that platform. So it's quite configurable. Yeah, well, you are within on rails to a certain extent. Yeah.
Mm-hmm. Yeah, and okay, so they have their standard designs. You can make some customization, like you say, on Rails. It will then pull a material list, cost it, and then I guess what's next? You find a builder to build it.
Yeah, so I
Is that
mean,
how they work that?
on Whole House, which is the first one, Travis Perkins, you design your house, you press a button, you get a full set of construction drawings, you then get a bill of materials, and you can walk in any Travis Perkins builders merchant in the UK with your bill of materials. Say, hey, I want to call off the ground floor lift, and they will have all them parts in stock, guaranteed price, and get them to sign. That's the way it works. You still need a builder to build it. On Top Hat, which is the version 2, which we did for Top Hat, who's an offsite DFMA house builder.
Yeah.
That's completely design a house, press a button. Once somebody still has to click approve, sends to the factory, drives the machines, and then the house comes out the other side after you pay for it.
Yeah. Wow, that's amazing. Okay. Cool. So we've got a few questions here, not too many today. So one of the first ones was, what's this, in Revit or Revit? Okay, so in Revit or design programs with rendering, how quick or effective is it to swap out products, like using VR selection for product selection?
I mean, to swap out a product in a tool like Revit is relatively quick. I'm not sure what I mean by VR selection. Normally, the process would be is you would export your Revit model to a game engine like Unity or Unreal, and then you would build the code in there to change stuff and swap stuff. But then that normally doesn't go back to Revit. But in Revit itself, let's say you've got a certain kitchen and you want to swap it out for another kitchen or certain manufacturer. It's pretty easy to swap it out. A couple of minutes, you can go and replace all those families with a couple of clicks.
Yeah. Okay. So because I've thought about this a bit as well. So say, if you were if you're an architect designing someone's house and you're sitting there with your customer and you want to have a look at, they want to try gold taps versus black taps and things like that. That's just a matter of swapping the objects out and running the render.
Yeah, I mean, yes, you could. In Revit, you could do it. So you can press a render button in Revit, sit back, wait 8 hours, and you'll have a nice rendering 8 hours later. There's tools for Revit which has real-time rendering built in, stuff like Enscape or Autodesk have their own version as well, where it does real-time rendering inside of Revit. So you can go and swap your taps and you have a photorealistic image, near photorealistic image instantly. If somebody knows how to use Revit, to go and swap out a couple of taps from silver to gold, a couple of seconds, and then real-time render done.
And then add-ins like Enscape and whatnot are the way to go to get a look at it.
Yeah, I mean, Revit does have its own built-in rendering now, I believe, since last year. But it's Enscape is a bit, in my view, better. You get better results with fanning about. Twin Motion's another one, but there's lots of plugins which do real-time rendering. The rendering inside Revit is intentionally slow. So if you press render in Revit, it uses mental ray rendering engine, and same one as 3D Max uses, which is a professional rendering tool, but it's a lot slower in Revit. And that's because you want to obviously buy 3D Max. So you could export your model out, put it in 3D Max, and render it a lot quicker. But the tools in Revit's not designed for professional renderers. It's designed for architects. I wonder what happens. Let's press a button and get a decent image. But there's plugins like Enscape or Twin Motion which increase that functionality and make it real time.
Make it quicker. Okay. Interesting. Okay. There was another question about that. I think that covers it though. Digitally make selection, so swapping out taps and whatnot.
What I would say is because I'm guessing it depends which angle that question's come from. If you're a manufacturer, you could be concerned, well, let's say an architect's put in a valve or taps, and then the contractors come on and then said, value engineering said, actually I can get a cheaper version of that tap for £9 cheaper, and put in a cheaper version, swap it all out on design and build where the contractor can do that. Some manufacturers might be concerned, well, the architect specified me, I put my BIM object in, but then the contractor who's only interested in money is when put in a cheaper version because he swapped it out. What I would say is it's that used to be the case, but in the UK it's starting to become less common because of stuff like the Building Safety Act. So architects now have to take more responsibility about the specification and what products are specified. And I think Rob did a previous presentation on this. So a lot of architects now, if they put in a certain door, let's say they put in a fire door from a certain manufacturer with a certain spec, a contractor would be very hesitant to swap that door out because the architect's proved that door works. He's validated it, obviously, with all the tools, and he's putting his arse on the line to say that door works. So if a contractor says, "I get one slightly cheaper," he's got to prove that door meets the same spec. So it's kind of, so what we're starting to see in our architecture business is it's starting to go back to the old way where, yeah, the design and the specification sits with the architect because they legally taken the responsibility in the UK. So what the architects are now saying, hey, if we take the responsibility, we're responsible for the spec. You can't go and swap that out anymore. So more traditional contract.
Yeah. Yeah. Okay. Very good. I know, having come from the building side, we're always trying to squirrel around, trying to find something that meets the spec that may be cheaper. So that's good. I think it's good that the design decisions are made where they should be.
And I think that's why if you can build in that addition, because yeah, when you talk about BIM standards for BIM objects, it talks about like stuff like classification, what data should be in the objects from like a specification point of view, etc. But what you've also got to remember is a lot of these design tools like Revit can do solar analysis, and you can do acoustic analysis, and you can do pressure drop reporting. So even though that might not be required in the standard as a minimum, if you put that data in, it allows people an extra excuse to use your content. If an architect can download one content from one manufacturer and one from the other, and one's kind of the basic, looks pretty, it's got a bit of data in to meet standards, or I've got this bit of content which goes above and beyond and helps me do my job to prove that design's going to work. That's why it's better to kind of just push your content to that next level and make the content that's useful for designers to do all that clever stuff.
Yeah, that's right. Yeah, I'm constantly talking to people about that. We came across some objects the other day, beautiful objects, but they didn't even have the manufacturer's name on them. So, they're the objects that they send out, so that, there's a big range, let alone any data. So, yeah, good to know. There's a question here, I think must be from a builder. What Revit plugins are your UK builder clients using for solar and heat calculations? Do we know that?
Yeah, so I think for early stage stuff, so if you're talking about like what architects are doing to make sure the building is somewhere near during the design stage, there's tools in Revit now, and they've just been increased on the last version to help that. So like you can do like your solar studies, your radiation, your light analysis, all within Revit itself. But then what a lot of people will do is once the design's done, that'll be normally exported into what's called a GBM file, and that's put into tools like Green Building Studio or IES is the one in the UK that's used quite a bit. And that basically is like a professional grade tool for that sort of stuff. And then there's other lighting tools, like I think DALI is one where you can do like professional lighting. So Revit will give you the tools to say, actually, that's the best option. But it's designed for the design purpose. It won't give you like a report with calcs on with the stamp. You still need to do that, and that's when those professional tools come in. But again, Revit supports export formats like GBM to export into the IES or whatever, and then the MEP engineer goes and does his calculations in there.
Yeah. Okay. So so you think they've upgraded those offerings on Revit? Is that Revit 25 or 24? Do you know?
I think it just came out a few months ago to be Revit 2025. So yeah, you built in a load of tools around green building sustainability, being able to do carbon analysis directly in the software. You could always do light and solar studies and lux level calculations.
Yeah.
But with the last release, it's now focusing on carbon as well. So kind of if I rotate my building 2 degrees this way, it's going to have 20 tons less carbon a year, etc. So if you just Google Revit sustainability tools, Revit 2025, you'll see there's a whole thing on it. Yeah.
Yeah. Okay. Someone's asked a question here. Does BIM Store have manufacturers MEP Revit families?
Yeah, it's what we're kind of known for. So I mean, we've probably got the biggest collection of valves in the world. So I mean, there's lots of other BIM, well, there's 3 other big BIM libraries. I'm not going to mention them, but there's 3 other big BIM libraries. One of them is a Wild West, where kind of anything's on. One of them is mainly architectural focused, and then there's us. And what I would say is our big strong point is MEP content. We have lots of valves, lots of boilers, lots of cable tray stuff. Yeah, lots of mechanical stuff.
Yeah, and to the asker of that question too, we're currently talking to a good chunk of some more of the Australian pipe and valve manufacturers as well. They think about doing some more content.
Yeah. Again, with valves, it's really important that the content is built properly, because a lot of people, a valve, you might have a valve, let's say ball valve, certain type, and then it's available with different pipe sizes. So what a lot of other people, the way I've seen valves modeled is they'll model every single size of valve and then offer that as like an individual individual object. So 50 mil, 100 mil, 200 mil. Now the problem is if somebody puts a 50 mil valve on a 50 mil pipe, and then let's say the design changes and that pipe changes to 100 mil, someone's then going to go and swap all those valves out. Where if you build the content parametric, what you can do is you can make it so if the pipe changes, the valve jumps up to the next suitable size for that specification of pipe. So you've got to think about good quality content, if that makes sense. That makes the user's life easier. Don't just think about I need a BIM object. Think about how it makes, and it's better for the manufacturer because you don't have to build 20,000 valves for every SKU. You're building one very clever valve, which covers all options.
Yeah, cool. Okay. Righto. One last question that's from me. I thought I've heard people say before that BIM modeling and modeling of buildings are solving problems that people didn't realize they have. When you hear that, can you think of any examples or any thoughts on that? Because I've heard that tossed around here and there.
Not really. I think what I would say is it's really hard to. I mean, if you look at why contractors are doing BIM or demanding BIM, it's because you want to reduce risk on construction to make sure everything fits, rather than have a set of architecture, structure, MEP drawings and hoping everything fits together in 3D. It allows them to check digitally if it works in 3D, it'll work in the real world. A bit like that shopping centre with the hexagonal grid I showed. It's to de-risk the process and you don't get unexpected problems on site. Same with timeline and 4D. The tricky thing with that is those big things would have been picked up on site anyway. Realistically, something turns up the sign and doesn't fit. Somebody somewhere was let's knock a hole in that wall and make it fit. So a lot of the problems you would never know existed, if that makes sense. It's kind of, but what it's doing is it's making that it's making it more objectified so you can kind of understand, does the design work, rather than because what a contractor will do, he'll have a set of drawings, architectural drawings, structure drawings, MEP drawings, all in 2D, and he'll put a risk on that. He'll say that looks like a good set of coordinated information, I'll put a £500,000 contingency on it, or it's a really crap set of information, it's £1 million contingency on it. So by having it digitally and being able to check everything fits in 3D, it just kind of de-risks it. And in the old days, there used to be a big discussion about, do you need manufacturer content? Because why don't you just use generic? Do you really need the boiler with all that detail on? What my argument is, you need enough detail to allow coordination to happen, because if you just put in a bit of generic content, perfect example, we were doing some really expensive apartments in BIM Technologies, and you had an air handling unit which sat in a cupboard. the cupboard was just big enough to fit this air handling unit in. And it was modelled just as a box because it was just a generic air handling unit. But because it was in a really high-end apartment, this needed 50mm insulation around it, and it was kind of to soundproof it. Now, if we had a BIM content for that exact product, which basically had that, that would have fit, if you know what I mean. But because the designer just used a generic object, it was wasn't accurate enough. So yeah, I believe obviously you don't want to model every single nut, bolt, and screw, but there is a need for enough detail to show the product dimensionally accurate, and then also for the rendering and visualization. Because again, a generic bit of content, you couldn't do the 3D visualization, so you'd end up paying somebody to remodel that later down the line. So yeah, I would say content that's useful for the purpose for everyone across the whole construction phase. But yeah, it's difficult to kind of answer that question, I think, without knowing problems we didn't know we had.
Yeah,
it's the way, it's the way the world's gone. So if you look at like other industries, they've been designing in 3D for years, and they would never. Ford's not going to go back to designing a car on a drawing board. Ford aren't going to go start designing airplanes on a drawing board. You're not going to kind of design a car in CAD and say, I'll just put a big cube where the engine is and hope that when we do get the bits, it fits. So we just evolving with the rest of the world, the rest of the industries. The only difference is construction and the AC industry is kind of lagging behind those. So if you want to see what the future of BIM is, just look at some of the cool stuff they're doing in automotive or aerospace at the moment, because we'll eventually just follow them along. That's kind of what happens. They call it digital prototype, and we call it BIM, but it's the same thing, really.
Yeah, no, awesome, thank you. And then I think that's why I have become involved and so passionate about it, because I just see in terms of construction delays and timelines and things like that, being able to get more and more right up front is and from what you've said today, it's everything from major government projects through to home builders, making those changes and getting things out of the ground a lot quicker.
Different purposes, different people. Sorry, one last thing. Different purposes for different people. So obviously, the big building, it's about reducing risk, coordination, etc., making sure everything's going to work. If you talk about a home builder, they build 20,000 of those homes a year, so you know if it works or not. You don't need a clash detector. You built 19,000 of them. The benefit of them is those additional. You can do 3D visualizations for marketing. And you can optimize the design. You can do so it's that you can drive a factory to produce houses out of factory. So that's the added benefit to them rather than the coordination, if that makes sense. Different benefits for different types of projects.
Yeah, beautiful. Okay. Righto. Well, thanks so much, Adam. We have used up the whole hour here, and thank you to everyone that's jumped on, been a part of this. We really hope you found them useful. Keep an eye on our marketing. Our next phase will be we're going to run we can get some podcasts going and get a hold of some really interesting people working in BIM and design and construction. So you may see that on our marketing. So if that interests you, jump in on that too. So thank you, and we'll leave it there.
Thank you.